Hi, good afternoon. Welcome to the continuation session of engineering mechanics, first unit for engineering physics students. And in the previous session, we learned about Newton's laws in inertial and non-inertial frame of reference. Let us know about Focault pendulum. This is a pendulum, like a simple pendulum, is designed with a weight of above 28 kgs and a length of wire of this pendulum is 70 meters nearly, and it is fixed in the northern hemisphere of the earth by the Focault in 1851. And he experienced that there is a rotational effect on the frame of reference. Means the vibration of pendulum is under the effect of rotation of the earth. As you know that earth is rotating with a constant angular velocity, and this angular velocity of the earth is affected the time period of the pendulum, and so that the pendulum is designed by the Focault, and his name it is called as a Focault pendulum. Now experimentally the earth rotates about its axis with a frame of attached on the non-inertial frame, and this Focault pendulum is designed by the Focault and with a simple pendulum model, and he explained about the time period of the pendulum in the frame of reference, and what is the value of this is to be explained. Like this is calculated in this fashion. Now the time period of this Focault pendulum, here this is north side of the earth and this is south side of the earth, and it is the equator. As you know that earth is rotated from east to west in this circle, and with a equator as a axis with a angular velocity omega. And suppose this earth is rotating like this, and when it is at an angle of phi from the origin, and thereby this is the pendulum where it is present here itself. This pendulum is attached here itself, and it is rotating with a angular velocity, and there is this horizontal component and vertical component of angular velocities are phi. And now this earth rotates one round in 24 hours. So the time period of the earth is 24 hours. Everybody knows that. So we can generally write that the time period of any rotatory body is T is equal to 2 pi by omega. That means 2 pi by omega. Here the two components are there, horizontal component and vertical component. The horizontal component omega cos phi is get cancelled from the northern hemisphere and southern hemisphere, and there only we have omega sin phi is the angular velocity component. And you know that this T is equal to 24 hours. So 24 hours is equal to 2 pi by omega sin phi, and this value is calculated. T is equal to, from this we will calculate T is equal to 24 hours by sin phi. This is nothing but 2 pi by omega. This is the 2 pi by omega is the time period of the Focault pendulum. So the Focault pendulum time period T is equal to 24 hours by sin phi, and this indicating that the Focault pendulum time period is affected by the earth rotation. Hence, this rotation of the plane oscillating will clockwise direction in northern hemisphere, opposite in the southern hemisphere. Thus, the rotation of the plane of oscillation Focault pendulum is demonstrated as a fact of the earth rotates about its axis. If the earth does not rotate with its axis, we have T is equal to 24 hours only. By the Focault pendulum experiment, it is proved that T is equal to 24 hours by sin phi means the earth rotation effect is there on the Focault pendulum. Right. The next coming to the rigid body and angular velocity vector. Rigid body, a body which is does not change any shape or any deformation of the body, any amount of force is applied on this body. So that body is called as a rigid body. A body which does not deform under any high amount of force is called as a rigid body. Deformed is nothing but whose face, whose size, whose shape does not change under any amount of force is called as a rigid body. The rigid body is generally taken as whose values are fixed, and so that this rigid body, let us take this is a rigid body, x and y axis on a plane, and this rigid body has a certain angular velocity. The angular velocity of the rigid body is also fixed value and it is calculated like this. So consider an arbitrary point A on a rigid body. This is the point A on a rigid body, and this is the component, normal component, and it is a lateral component, normal and lateral component. These two components are resulted. Omega and angular velocity is alpha about the O. Let En and Et are the vectors drawn A as tangential and normal to the body. And now, with respect to the some fixed frame S, the infinitesimal S frame of reference, rotation angle d theta is equal to, small angle is rotated, then d theta is equal to omega into dt. That means angle is equal to arc into radius, like that. We will calculate it. Here displacement is equal to velocity into time. D theta is angular displacement, omega is angular velocity, dt is time. So angular displacement is equal to angular velocity into time. That is the equation. So omega is equal to d theta by dt. And here this is the angular velocity of the rigid body. And coming to the equation of the rigid body, then we have general equation, velocity V is equal to r bar cross omega. V can be written as dr by dt. R is as it is, omega is d theta by dt. So that r cross omega. So a velocity V is equal to r bar cross omega is more good for the rigid body. Similarly, we can write acceleration. Acceleration is obtained by means of differentiating this equation. dv by dt is equal to r bar is keeping as this, and now d omega by dt. So this can be written as dv by dt plus omega cross r bar, and thereby alpha is equal to alpha dash plus omega cross r bar. This is the equation in the case of a rigid body. Now let us come to know about the center of mass as you studied in intermediate. The mass of the body, entire mass of the body is assumed to be concentrated at a point in the body, and that point is called as a center of mass. The center of mass of a two particle system is explained with simple diagram. There are two particles, one is of mass m1, other is mass of m2, and this is the center. From the center, and this is the axis point, m1 is present at x1 distance, m2 is present at x2 distance, and center of mass is present at x1. You can write that center of mass of this two system body as xcm is equal to m1 x1 plus m2 x2 by m1 m2. This is extended to n number of bodies. xcm is equal to m1 x1 plus m2 x2 plus m3 x3 plus and so on, and by m1 plus m2 plus m3 and so on. This is the center of mass of a particle body along x direction. Similarly, y, you can write y. ycm is equal to m1 y1 plus m2 y2 plus m3 y3 plus and so on by m1 plus m2 plus m3 and so on. In general, we can write this rcm is equal to mi ri by m. Means mi ri means m1 r1 plus m2 r2 plus m3 r3 plus and so on by m1 plus m2 plus m3. This is the position vector formation. The same can be written as also in the form of integral form. This x is equal to xcm is equal to m. This is total m, keeping as a constant 1 by m before, and mass is getting varying, integral x into m. And so that we have xcm value. Similarly, the same way we can write RCM is equal to 1 by m integral RDM. This is the integral form of center of mass. This is general calculation of center of mass. So center of mass is nothing but where the entire mass of the body is concentrated at a point of the field is called as a center of mass. Coming to the Kepler's laws, as you are also studied in intermediate about the rotation of the planet explained in the solar system, and every planet rotates around the sun with a one Focault as a sun, and that is explained by Kepler, and hence it is called as a Kepler's law. First Kepler law is a law of orbit. This gives that shape of a orbit of the planet around the sun with one Focault as a elliptical shape. According to this law, the path of the planet is a elliptical one. And this second law tells that law of area means with one Focault of the sun, a planet which revolves around the sun occupies equal interval of times equal areas. That means the area swept by the planet is equal to constant. So the amount of area here, the same interval, amount of area covered here also equal. This is called as a law of area. So according to this law, the radius vector drawn from the sun planet sweeps equal interval of times equal areas. So aerial velocity is constant. Third law is law of harmonic. Means this gives that how the time period of the planet with respect to the radius or length of the planet from the sun, and t square is directly proportional to a cube, where a is nothing but the distance between sun and planet, t is the time period of the planet, t square is directly proportional to a cube, and we can taken that is the square of the time period of the planet is directly proportional to the cube of semi-major axis of the planet in that elliptical orbit. This is Kepler's third. And now Kepler's third law, center of mass. These two are studied in intermediate, and also this rigid body angular velocity is simple, and Focault pendulum is the new one to you, and you can just go through the Focault pendulum. And with this engineering mechanics is over, and you get prepared the total material, the total syllabus is present in the material, and you can go through the material also and work hard through the taking the material. If you have any doubt, you can just go through the video and clarify your doubt, and then once again read out the material. Thank you. All the best. All. Bye.